10.8 geometric probability. So really we talk about probability. When I talk about probability, we have a number of possible outcomes over favorable. Favorable means what you're actually finding the probability of. When I talk about geometric probability, this is a lot of times we're using either the length segments or the area of a shape to find our probability. So looking at this question right here, if I were saying, what is the probability if I were to pick a point S on AD, what's the probability would be a BC? So this is where I would need to know my length. The total is always your largest shape or your furthest distance. So my total here would be AD because that's how long the length is. So that would be the length of AD. And the probability of being BC is the total length of just that intended outcome, BC. So if I look at this problem right here, it says point P is chosen at random at FJ. The same from F to J, a point is chosen. Now this is where you have to figure out the total of FJ. So if I find the total of FJ, remember it's going to be your larger number. So in this case, it's 15 minus your smaller number, and it's the absolute value of that. When you're finding distance, it's always large minus small, the absolute value, because distance is never going to be negative. So the distance from F to, now you could also count all these, if you really want to, you could count. So then the bottom of the fraction, we have 11, because that's our total distance. What's the probability? That's going to be in G to H. So if I found my length of GH, my GH length is going to be my largest distance, which would be 11, minus 6, which would be equal to 5. So the probability that you would land on GH would be 5/11. So now I'm actually going to have to draw a line myself. Now I have to make sure I draw a line that kind of makes sense in this scenario. It says a commuter train runs every 25 minutes. So this length right here, it runs 25 minutes. This total length is 25. The same, what's the probability that the commuter will have to wait at least 10 minutes? So you have to think right here. This would be like 10 minutes right here, if there's 10 minutes of time right there, but it's saying at least. So they could wait 10 minutes or longer. So we're actually looking for this length because they could wait 10 minutes or longer, at least 10. My total distance, my total time is 25. And I have to think, how much time is right here? Well, this is the time that would be less than 10 minutes. So if I have to subtract those two off, 25, because that's my total, take away this 10 would give me 15. Now, when you're doing probability, you could either have your answer in simplified fraction form or as a decimal or as a percent. Now, if you're going to be doing the percent, once you have that decimal, that's 2 spots to the right. So I don't care if you have it simplified fraction, decimal, or percent. Right now, I want you to try to do B by yourself. So here, total of 40 minutes is every time the ferry runs. It says no more than 25 minutes. So now I put that 25 there, but then when I'm thinking about this, it's saying anytime in this period is my intended outcome because no more than 25 is the max. Here I had to subtract. Now I do not have to subtract. My intended outcome is the 25 minutes. So 25 minutes over the total minutes of 40 would be either 5/8, 0.625, or 62.5. For C right now, I want you to try to draw the picture first. Try to draw the picture first. Pause the video, try to draw the picture. So your picture should look something like this. 30 seconds, red light, 15 seconds, green, 10 seconds. So now that changes our total because this is one total length. Pause the video, I want you to find the probability that you will arrive at a green light. So my intended outcome is the 15 because that's how long the green light is over my total, which is 55. So either 3 out of 11, 0.273, or 27.3%. Now we're getting into the area, geometric probability using area. So again, my intended outcome is always my small shape I'm talking about. My total outcome is usually your largest shape. So right now, if I'm looking at this inscribed circle inscribed into the square, what's the probability it's going to hit the shaded region? So I have to kind of think this through. Now, when you're looking at a picture, always look to see if something's cut out. It looks like the circle is cut out. That means the area of the shaded region is my intended outcome. I have to first figure that out. So if I'm going to cut this out, I'm going to have to find the area of my square and subtract the area of my circle. So right now I want you to pause the video and try to do that. If you're like, wait a second, I don't have the radius. Remember, if this length right here is 5, this length right here is 2.5. So I want you to try to find the area of the shaded region first. So 5 times 5, subtract 2.5 squared times pi. I rounded to 5.37. So that's the area of the shaded region. Now I have to think, what's the area of my total? Again, typically your largest shape is your overall outcomes. So my overall outcomes would be the area of that whole square. So that's this part right here. So it'd be this over 25, because the fact that 5 times 5 is 25. You never want to leave your fraction as with decimals in it. You never want to leave a fraction with decimals in it. So if you divide those out, that would be equal to, well, I don't know the percentage. 537 over 200, or 2,500. This is where I would actually leave my answer as a percent. 21.48% is what I would have. I want you to try to do B by yourself right now. So you should have gotten 50%. Now, some people at this moment right here, they realize that this triangle is half of the total square. And if you realize that, then you know it's going to be 50% chance that would land in that shaded region, that triangle, the two triangles split up. Either way, that should be 50%. So problem 4, what's the probability you're going to land in the shaded region? So I want you to pause the video and try to do this by yourself. Pause and try. So my shaded region would be this circle, subtract my smaller circle. So 4 pi squared, because that's my radius of my inner circle. Subtract 2 pi squared, because that's the area of my smaller circle. So that's my intended outcome. My overall outcome is the large circle, so 8 squared times pi. So area of my intended outcome divided by my total area, which would be 18.7%. And there you have it, chapter 10, all done. You're amazing. Have the crowd go wild. Have a great, have a grand, have a wonderful day.